All right, so we're going to go ahead and get started. We have about 33 or so folks online. I'm sure we'll have another few folks join us. And I will repeat this at the end of the video, the same as I did yesterday. But we applied another patch because we had still a small cluster of folks yesterday that were still impacted by that grading bug. So if you do the same thing that we had you do yesterday, which was open a command terminal in your VM, type the words git, G-I-T, space P-U-L-L, git pull, enter. If you're up to date, it'll tell you you're up to date. If the new patch to help that small group of affected folks has not been applied, it will apply it at that time. I've also sent out a message via Canvas, so in case you missed the beginning and end of this video. Now, once you do that, it is imperative that in order to have those grades loaded, you start and stop a lab. Every time you stop a lab properly, it will try to upload all of the recorded and saved grades. Now, we had our engineer look at a couple people's profiles and VMs yesterday that were reporting that they were unable to see their grades populate. And at least for two of these individuals that he looked at, they were not stopping the labs properly. You have to read the lab prompt from beginning to end and follow those steps. Where you start the lab is also where you stop the lab with the stop lab command. If you do not do that, it will not grade your lab, save, or try to push those grades. So if you're just closing out those terminal windows that you've been working in, nothing will be saved. You have to stop lab to save those results as well as try to upload any completion grades. So with that being said, I'll repeat this at the end and I'll just make a special note. We understand that there is an issue with the ARP spoof lab where it is not picking up when people are doing that correctly. So rest assured, by and large, most of you that have contacted us have been doing that lab correctly. It just simply isn't recording that it's graded. So we've gone ahead and pushed credit manually into those for that lab. And the DNS lab, we noticed that there were some issues with rendering from the code where we wrote the lab into the web page where it's being displayed. So if you have not done that lab, you can go ahead and skip it. If you have done that lab, great. What we'll do is after this video, we'll be exempting that lab from the point scaling as well as the ARP spoof. So you will see whether or not you completed it. However, the points for those two labs will not be counted towards the total point count. And then yesterday I meant to mention, and I will mention yet again, if you've completed all the labs that you can so far and need some extra things to do, we do have a Metasploit lab that's available. That is a challenge bonus lab. And that is something that's going to work you through using the Metasploit framework, just getting familiar with that. It's a very simple lab. So I would encourage you, if you have time, to give it a try. And I will also warn you that for the Metasploit lab, it has to pull in two very robust Dockers, a Kali Docker, a Docker with the Metasploit framework loaded, as well as a Metasploitable Docker for you to exploit. So it is going to take a minute to load those. Those will take considerably longer to load and come up than your other labs, but you should not have any issues with those. So that being said, we'll go ahead and get started with day 3 training. So for day 3, we're going to be this morning looking at cross-site scripting, and then this afternoon when we come back at 1300 with Nicole, she'll be taking you through SQL injection. So really today's focus is on web-based exploitation and security. So we're going to start off this morning again with cross-site scripting. So before we get into the basics of cross-site scripting, or the basic types of cross-site scripting, I should say, we need to just kind of explain cross-site scripting, give a good description, summary of that. So with cross-site scripting, the idea is the user, their browser is going to be manipulated. So basically their browser is going to be doing something. And there's 3 basic types of ways that cross-site scripting can happen, and so we will talk about each of those as we get into the lesson. We'll talk about persistent cross-site scripting, reflected cross-site scripting, and DOM, which is domain object model cross-site scripting. So for each of these, there's a different way that it's performed, but in each of these, the user's browser is what's going to be facilitating those tasks and letting something happen that should not actually be happening. So in order to really truly understand this, we need to go back in time. So We're going to take you back to the year 2005, when you and I and most of us might have had MySpace pages. Fun fact, MySpace is still an active website. It is turned from what it used to be, which was like the original social media platform, into more of a connect to music and artists type of platform. But yes, MySpace is actually still a thing. So I encourage you to check that out. Maybe sign up, help out MySpace. I think they're struggling. Anyways, so the year's 2005. Your first friend is Tom. If you remember, if you ever had a MySpace page, Tom was your first friend. And all of a sudden, you have this friend that you have never heard of, and his name's Sammy. You're not sure how he got added as your friend because you thought Tom was your only friend. Well, we're going to take a look at the Sammy worm. This is an infamous worm that was spread via persistent cross-site scripting. Now, this, what we're about to watch here is a very basic, fairly non-technical explanation of the Sammy worm and what happened. So I want you guys to watch and listen to this. And then I also have the link included here, which you can check out later, where the Sammy worm is actually explained in very technical terms. He goes over the code that he created and implemented piece by piece and how it works. So if you're curious about the technical side of it, the link is there to figure out how Sammy got this worm working. But let's go ahead and check out this video concerning the Sammy worm and how that particular worm took over MySpace.
Just kind of sat in my chair, head spinning, like, what do I do? The biggest website on the internet right now is down.
Oh.
Because we didn't test this, I didn't know this was going to happen.
Oh. Give us 1 second here. We are going to...
I just kind of sat in my chair, head spinning, like, what do I do? The biggest website on the internet right now is down, and it's because of me. MySpace is the #1 site on the internet at this time. This was 2005. It even surpassed Google. So I was about 19 years old. I get onto MySpace and I set up a profile. And I started playing around with the MySpace website, trying to see if there were any issues I could exploit. Found a vulnerability in both MySpace and browsers that allowed me to write code and put it on my profile. The code I had written was actually giving me a ton of power. I had full control of the person's browser. So what would happen is, if you visited my profile, you would add me as a friend, but the code would then replicate to your profile. So anyone who visited your profile would also add me as a friend and add the code onto their own profile. So from there, it became a worm or a virus. So I wake up in the morning expecting a couple new friends. I go on myspace.com and I now have like 10,000 new friends. Of course, it was exponential, so the next hour I saw 50,000 people on my profile. Now, deleting my profile doesn't really get rid of the virus or the worm, right? It's kind of like a cold. Like, just because you're cured, if you spread it to 100 people, it doesn't matter. They still all have the cold. So I go into MySpace and I say, delete profile. It says, okay, your profile will be deleted in 24 hours. It's just stuck in this frozen state for 24 hours while this worm continues to spread across MySpace. I'm at over 500,000 friends, and I'm just blown away. I don't know how to like solve this problem. It was basically another hour when it hit over 1 million people. So at this point, it was less than 24 hours since I had launched the original worm on my profile. And now I'm just refreshing, and I hit refresh, and it says, this profile has been taken down. I'm like, finally. So hopefully they took down the worm and everything else. So I go to my girlfriend's profile, and it says, this profile has been taken down. And I'm like, oh no, what just happened? So I go to myspace.com, their main page, and it says, MySpace is down. And I felt terrible. And I'm thinking, maybe I should drive over to MySpace, bring some coffee and donuts, and be like, hey guys, I'm so sorry. Can I help? And a few hours later, I checked and MySpace is back up. Then I kind of just waited. A day went by, I woke up, nothing happened, no cops. A week went by, no one has contacted me at all. After 6 months, I buy a new car, a Porsche Boxster. I'm walking down to the garage in my apartment, and the elevator opens, and I see my car, and I see two kind of big guys standing next to it. And I'm walking up to them, I'm like, oh no, like I'm getting carjacked. These guys are gonna beat me up and take my car. And as I'm walking up, two guys walk up behind me, and I look around, I'm like, oh no, I'm surrounded. What's gonna happen? They say, Sammy? I'm like, yeah, we have a search warrant. And they all show me different badges. And we go up to my apartment, and there are a dozen agents, all with guns, going through everything. And I'm like, whoa. People actually bust down doors with guns when they're after a computer hacker. They go through anything with technology, anything with a chip, anything with data. They take it, and then they leave. And I'm like, am I free to go? And they're like, yeah. Like, you're not arrested, we just have a search warrant. And I find an attorney in LA, and he says the DA wants to put you in prison. I had no idea what was gonna happen. After about 6 months, my attorney came back, and he said, all right, here's a plea that we can actually take. Basically, you'll pay some money, maybe like $15,000 or $20,000, and you'll go to probation for 3 years, no prison. You can have one computer that's not on the internet. At this point, I really have no options. I say I accept the plea agreement, and that's that. I kind of started a new chapter of life because I had spent my entire life just in front of a computer. And finally, this light got me out. I just spent a lot of time doing other things that I think normal people did. As part of the deal, I had to do 720 hours of community service. So at 5 a.m. every Saturday, I'd wear this orange jumpsuit. I'd drive my Porsche to a waste facility, and I'd get in a dump truck. I had to basically just pick up trash on the side of the road. And that was about 2 years. 3 years later, everything was off my record. I could touch computers again. I could use the internet. I was a normal citizen, rehabilitated by the state of California. That day, I went out and I went to the Apple store. I bought a laptop, pulled out the laptop, turned it on, and I opened the web browser and I go to a website. I looked for a few minutes and then I shut it down. And I was like, all right, I'm just gonna go hang out with some friends. And that was pretty much that.
Okay. All right, so that's just a little story about Sammy and the Sammy worm. So if you're interested, there is a podcast called Darknet Diaries. It's D-A-R-K-N-E-T, Darknet Diaries. This podcast, I subscribe to it on Stitcher, but they also have a Sammy worm podcast on there. Very, very good, very much more in-depth. It's, over an hour of, kind of discussing this worm and what happened. And it's very, very interesting. I will say that Darknet Diaries also has a lot of other very interesting cybersecurity kind of hacker-ish type stories. So it's pretty educational. So check that out if you are interested. But as far as Sammy goes and this worm, I wanted to introduce you to this to give you an idea of how cross-site scripting can be used and some of the dangers of it. Now, obviously, this was something that was unintentionally done by Sammy, but there are many instances of cross-site scripting being used for things like theft and man-in-the-middle. MageCart is a great example of a cross-site scripting issue that was exploited with very large retailers, specifically British Airways. I believe it was British Airways and Newegg were affected. So they were affected by this MageCart, and the idea behind that was it utilized cross-site scripting to take a copy of payment information that someone was entering into their browser and send that off to the bad guys. It also did this via HTTPS, so as Nicole was mentioning yesterday, that information blends right in, very hard to detect, especially if you are looking for something because it is encrypted. So again, there's a lot of different ways that cross-site scripting can be utilized, and so that's certainly a vulnerability you should be familiar with. Now, in order to go through this, we are actually going to be accessing the range. And so I'll leave this up for a moment and then I will pull it up myself. But I would like for all of you to follow along in your own browser if possible. go ahead and open your VM in the range. And you're going to open a Firefox web browser. Inside of that web browser, you're going to type the following address exactly as it appears here. It's HTTP, there's no S because this is internally hosted. You and me and the people on the range are the only ones that can see this server. So it's http:// the address :8080, that is the port. So we have a full socket here, /webgoat, capital W, capital G. I'll leave this up for just a few more minutes to let you guys get this address copied down into a browser and open that up. And then I will switch us into our VM and show you WebGoat so that you can see that. Now, if you're already on that page, you can go ahead and click the register user link right under the login prompts and make your own account. There are some specifications. I believe your username and password both need to be between 6 and 10 characters. So it's just a character limitation. You don't need to worry about special characters or complex passwords, because again, this is internally hosted and no one else has access to this except for us. So make sure that you register yourself there with an account. And I will tell you that there is much more inside of WebGoat than just the cross-site scripting and the SQL injection, and there is a whole introduction to this platform. It is a platform that you can download yourself and run internally on a VM or a Docker. However, if you do so, make sure that that particular platform is properly protected from the internet, because it does make it a vulnerable target. So you want to be careful if you are in fact using this on your own. So I'm going to switch us into our browser. And again, I would like for everyone, if possible, to follow along. All right, we'll see. All right, so after you log in, you should be able to see this navigation tab on the left. And I'll pull this up just a little so you can see, again, there's the address up at the top. It's 10.101.20.131:80 WebGoat. Now, once you have registered yourself, I will also point out to you, besides from the introduction to WebGoat, you'll see over here on the top right-hand corner, this is your little user. So here is username, role. I have just logged in with a username I've created. Next to that is your report card. You can click on that and you can see the number of lessons that you have solved, the number of lessons that you have done, okay? And you can actually reset these and try again as well, and I'll show you how that looks. So for the purpose of this morning, you're going to be locating A7 on the far left-hand side, which is cross-site scripting. Right here, A7, if you open that up, it has one tab under it. It's cross-site scripting. Click on that tab and your lessons will open up. So you'll see these lessons. I'm going to reset because I ran through to make sure everything worked. So you'll see that green turned back to red. If you reset the lesson, if you have already completed an exercise, any exercises or quizzes are in red. If you've already completed those, then they're going to turn green. So if you want to turn those back to red and try it again fresh, you just reset the lesson here at the top. That will also clear out your report card. So your report card is really just a current status. If you reset all the lessons, your report card will reset back to zeros as far as completed items. So again, you'll see here, we are at cross-site scripting, lesson A7. There's only one tab for cross-site scripting, and you'll see we have 12 tabs here that give us all of our content information. So we'll be going through this briefly, and I have asked you to pull this up on your side so that you can do the exercises that are contained within these lessons as we go along. And so I'll be pausing after we discuss some of these things in order to allow you to do these exercises. All right, so the first page is just the goals and concept behind cross-site scripting and what we are going to look at. Specifically, we are going to be looking at reflected cross-site scripting and DOM-based cross-site scripting. This is because persistent cross-site scripting is something that requires you to store your script to store your exploit or script, if you will, on the vulnerable server at the remote end. What we are going to be focusing on is how can we take advantage of a website that is vulnerable to cross-site scripting and cause the user's actual browser to take some action based on code that we are injecting or they are feeding, or being fed rather. So we can move on to the second tab. As you see, you'll just click to the second tab here, and that's going to take you into the information. Now, for the most part, we are going to be looking at URLs, web forms, and specifically talking about JavaScript. This is because when you look at websites, for example, the websites where you see the labs prompts that we've hosted for you, those are what we call static websites. It's just a rendering of HTML and or CSS. It does not contain any forms or mechanisms to take input or change things. So it's not very dynamic. So these static sites are not as user-friendly and not as functional, but they're much safer in some ways. So obviously, on the internet today, most of the websites that we're going to be going to are going to do things like collect information from us, allow us to authenticate and log in, allow us to search for things. Just Google's search page, for example, is a great example of a page that requires JavaScript to even function, because it's going to take the information that you give it in the search bar and use that in order to perform a function for you. So that is what makes cross-site scripting something that there are still a lot of vulnerabilities out there. Even though we know that this is a serious flaw, it is very hard because so many websites rely on JavaScript and different functions through forms or query fields and search fields and things of that nature. So that's why this is still a fairly prevalent vulnerability, just because of the prevalence of the functions, the website functions that this vulnerability affects. So we're going to be looking first at some examples, and I think that these examples will help you to conceptualize this. Now, before we look into these examples too deeply, I'm actually going to show you how to access the web developer tools. So you'll see here in the quick example, it says the JavaScript console in the web developer tools. So if we scroll up to the top of this browser, and we hit our little three lines for the menu, you'll notice if I scroll down, I've got this window blown up so it's easier to see. If I scroll down in this menu, you'll see web developer. If I click on that, you're going to see a number of web developer tools. So all of these tools are really pretty awesome. They allow you to do a myriad of things. You can see if you open up this console, you have a lot of different things that you can do. Specifically, me being a network person, I like to use the network one because it allows you to actually see exactly what's being sent and received. So again, there's a lot of different things that you can do here from inside of this. Now, back to cross-site scripting. So the web developer tool and that tab in order to access it is something that you'll want to keep an eye on, because you will be using those in the lab following this lesson. So we do have a lab that you will do inside of Labtainers, along with the examples and practice that we'll be doing here live inside of the lesson. So here are some quick examples. In this case, they're just asking you to input these particular JavaScript items into our console. And once you input these, what you will see is that, so these are JavaScript functions, and it's an alert function. So what that alert function does is it will cause a small pop-up window, and whatever happens, or whatever is inside the window, I should say, is what's contained in these parentheses. So inside of these parentheses is what you're passing to the function being the alert box. So the first one is just passing a string to it that says cross-site script test, which means this first item here, when executed, will simply pop up a window that says cross-site script test in a window box. The second one, on the other hand, will actually pull the cookie for your current session and display that. So you'll notice that the first one has quotes around cross-site script test because this is text. I just want to simply send this string inside of the box. For the second one, where you see document.cookie, this is actually calling for a piece of information. So the alert window will have the cookie information, which is being called through this function of document.cookie. That will look to find the current cookie for your browser and display that inside of that alert field. Finally, down here, so once you can see using the web developer console, and here in a minute we'll pause and let everyone try that. Once you can see that these two particular actions taken in JavaScript, if given directly to your web browser, will result in those alert windows, you can also understand that if you have something such as a submission form, you can actually use that and insert JavaScript into that form. So in this case, what we need to do if we're going to be inserting it into the web page from the front end rather than from the developer tools is we need to add the script tags. So as with the first one, you see alert and then the function information. This is being passed into the web console, and therefore it does not need those script tags. The second one has script tags in it, where you see the script inside of the two greater than, less than signs. This lets us know it's a script tag, and then at the end we're closing that script tag. That basically lets us know everything within that open and close tag is going to be the JavaScript to execute. It is the same syntactically as above, where I have alert and then XSS test inside of quotations. This lets us know that we will have an alert window that's going to pop up for us. So what I'm going to do is I'm going to let you see this try it. You can use Chrome or Firefox, but I believe Firefox is what you're working with on the VM. So just go ahead and use the Firefox browser that you are in. Open up a second tab, copy your URL for WebGo into that tab so you have that same item in there. And then in that second tab, so that you have your first tab to come back to when we resume the lesson, what you can do is open the web developer tools that I showed you and open a JavaScript console and type the alert and document.cookie, just as you see it here, without the period, just what you see highlighted. What that will do is that will cause an alert to pop up for you. Now that alert that pops up for you will be the actual cookie for your web page. And in this particular exercise, they want you to do it for the second tab and then come back and do it for the first tab. Compare those two cookies and then answer this question as to were the cookies the same on each tab. And I'll just give everyone a few minutes to give that a try. All right, so continue working if you are still working on making this happen. What I've done here is I've pulled up, at least in one tab, I didn't pull up 2 tabs, but I've pulled up in one tab our developer console. Now you probably got this message, and hopefully you figured out that if you just follow what the message says and type allow scripting, it will allow, or sorry, allow pasting, it will allow you to paste. Because I'm lazy, and so I pasted alert and then document cookies in rather than typing it. If you typed it, you shouldn't have had any issue. But once you either paste or type in alert and then document.cookies, that is the function calling in the cookie information. What you should have is this window. Again, this window here is what happens when you type in, when you use the alert function. So the alert function itself brings this window up on your page. So your browser spawns or creates this. And then the cookie itself, you'll see, is contained here. So I have this SYKT3WGQ, this long string, which is my session cookie. So I'm going to click OK for that. And so what they want you to do is they want you to check 1. I'm going to close out my developer tools and show you what you should be doing at this point. We are going to open a second tab. We are going to go to the same website. And once we are on this website, we are going to, open our developer tools. Just like I showed you before, from developer tools, go to web console. This is going to open up your console. And now if we take this same JavaScript right here, not with the script tags, because again, we are passing this straight into it rather than trying to render it from a form or something of that nature or reflect it back. So we are going to type alert. And you'll notice here I have another cookie. Oops. Oh gosh. Did not mean to do that. Shoot. I refreshed the wrong tab. Hang on. Fun. Yeah, live demos. It happens. Sorry about that, everyone. I refreshed the wrong tab. There we go. This was the tab I wanted to refresh. Coming back down here to cross-site scripting. Again, just running through this again for you all. Going in web developer, web console. And down at the very bottom of my screen, you can see the web console where I'm typing alert and then document.cookie. All right, so again, here's your cookie information. Now, I don't remember if they made all of these pages vulnerable or not. I'm just going to go ahead and try, see what happens when I paste a little JavaScript into this web form, see if it's vulnerable. Are you sure? Try using a different type. So basically, it is not vulnerable because it's just looking at this and it's scrubbing it properly, meaning that it is not allowing those special characters to allow the insertion of this code. So we are looking for an answer here of the cookie question. Are the cookies the same on each tab? Yes. You'll see you type yes. It says, congratulations, you have successfully completed the assignment. So again, I showed you on those 2 tabs how to pull the cookie. We saw the same cookie, that SYK, I believe. We saw that same cookie on both pages. So that cookie is based on my user and myself being logged in. Now, when we look at cross-site scripting and we talk about how this can be used, we have to think about the common locations where cross-site scripting exploits or vulnerabilities may occur. So obviously some common locations would be any search fields that echo back a string. So for example, I just used the example of the Google search web page. When you put something in the search information there, what you should see come back in the URL is a question mark and then a search equals some sort of information. So Google is actually not, obviously they are not vulnerable to cross-site scripting, but any type of web search page where you would put in the search and you would see that information carried into the URL and echoed back at you is somewhere where we may see a vulnerability because the proper sanitations and control measures have not been put in place. Furthermore, input fields that echo user data back, so anything that takes user data into a web field and then actually runs it across the JavaScript on the page locally and echoes that through the browser. So this means that that never actually went to the server and came back to you. What it was is you put information into a form or a location on a web page, and that had some sort of JavaScript action taken on it, and then it was echoed back to you. You may also see areas or places where you can find vulnerabilities in error messages that are returned based on what you supply, or hidden fields that contain user-supplied data. Message boards are a really great example of a way that user-supplied data is going to be echoed back to or presented in your page. This is something that you will experiment with inside of your Labtainer lab. So you will be using something similar to a message board. You'll be using a mock social media site, and you'll be putting information there that basically when someone visits your profile will take an action. So any type of message boards, free-form comments, profile information that renders without any type of filtering for scripting and things like that could be common areas where you might see this vulnerability taken advantage of. And again, finally, HTTP headers, again, just going back to any time that you see information echoed back, reflected, or contained in that URL, that's at times an area where you may be able to take advantage if there's no special character modifications or encoding done. So why should we care? Well, I did mention MageCart and the case where we had, for example, the payment information being stolen. So we just looked at how you can very easily access the cookies. Now, I was accessing my own session cookies within my browser, but that was only because I used the JavaScript function of an alert, which would send me the information about my cookie. What if the JavaScript function, rather than alert that pulled the cookie information, was doing something else? It was sending it to someone. Well, then someone is able to steal my session cookie and potentially use it to masquerade as me. So this is going to be a problem. Just like our MageCart example where our payment information was stolen because a copy of what was put in the form was also sent off to the bad actor, you can also see the collection of credentials in this exact same manner. Whereas rather than a credit card number that was putting in, it's your credentials that we're seeing being put in and then copied to a adversary. You also may see cross-site scripting examples that can redirect your page to a non-friendly site. What this means is that if there is something that causes your browser to take an action without you interceding or you being aware of that action, so that script is automatically going to redirect you, this is an issue because now you may be at an adversary or an attacker's site and not actually understand or realize that. So again, these are just some of the different ways that you can see cross-site scripting used. Obviously, things like a defacement of a page, inserting hostile or inappropriate comment. These would also be, or content rather, these would also be ways that cross-site scripting may be taken advantage of. These are probably less serious than the loss of credentials or cookies or sensitive information, but they are still definitely a concern. Oops, oh, sorry. My mouse is very sensitive. I apologize. All right, so here's an example of the insertion of information or hostile information, what have you. So when you see here in this tag, you'll see the image right here. This is an image tag. So this is how we would present an image from a source. In this case, you have an image tag that is pulling the image source from this malicious website. What that means is generally, if this website and this information at the website is not actually a picture, you may just see that broken thumbnail that you see when an image does not load properly. But what will happen is your browser will direct to that particular website, that URL that you see there, the http malicious.site.com, and it will have accessed that. Now, this is an example where they have a JPEG here, but you also have the ability to point to something that may be something like a JavaScript itself. So you have a much longer JavaScript file that is stored on a web page that's being accessed, or something of that nature. So again, this is just something where that image is going to be, your browser is automatically going to take that image tag and try to reach out to that website without your authorization, or sometimes even your knowledge, because all you may see is a small broken icon, broken image icon. Now, the idea of cross-site scripting attacks coming in conjunction with phishing is very interesting. This is because, for example, if we take, again, I'm just going to reiterate, Google is not vulnerable to cross-site scripting, but I'm going to use it as the example because everyone knows Google. So Google is a search page. If I go into Google and I search, for example, cats, and in my URL that is returned, I see the base URL of that website, so google.com, and then I see question mark search equals cats or whatever I put in. What I have there is something that, if it were vulnerable to cross-site scripting, has that base URL of Google, so it looks safe. It is, in fact, a safe web page. But rather than a simple and benign thing like a search for cats, where I see that question mark search equals, I'm going to insert something that will redirect or take some malicious activity. So because that URL is going to be subject or vulnerable to cross-site scripting, it's going to take what I write inside of there. And once the user sees, oh, this is Google and this is a search for cats and I should click on this link, once they go to that link, the information and script inside of that URL is going to actually have the potential to lead them to another malicious site or take some activity inside of their browser via the script that they're unaware of or they wouldn't necessarily care to have done, such as stealing cookies. All right, so we talked about, in the beginning, we briefly discussed the types of cross-site scripting. So with these different types, we have the reflected type, we have the DOM base, it's also technically a reflected type, and then we have stored or persistent. So like I mentioned, we're not going to be doing or looking at much with stored or persistent. This is something where it is something that, you know, the actual database, file system, website itself, or some other object has been compromised and that malicious information is being stored there. This means any time that a user goes with their web browser to that site, that malicious information is going to be rendered through their browser. I would say an example of this would be if you had some scripts stored in an ad. If you recall a few years back, I think it was Yahoo, but I think it was Yahoo. They had a lot of malware and things that occurred inside of their advertising spaces. So basically, they sold iframes and other mechanisms of embedding stuff into their website. They sold these areas on their base page to people for advertising. Well, some of these advertisers weren't actually like a legitimate company that was trying to advertise a product or service. It was actually bad guys that used what we call malvertising in order to create something that looked like an ad to the user, but also included script that was running and rendered by the user's browser when they actually accessed that page. So the scary thing about this is that that area on the page was sold to these people that had bad intents. They injected their malicious scripts there, and then anytime a user went to Yahoo's page, for example, their search page, they were going to be infected or subject to that particular script and code. So that's just kind of a basic example of what that looks like. Now for DOM type and reflected, that's what we're actually going to be playing with today. So specifically looking at DOM, this is something where the malicious content is something that is based on the domain object models and reflected back through the user's browser. So when we looked at the things that we just did a second ago, where we had an alert that if we put an alert into a query field and then that echoed back to us and alerted into our browser, or our browser took action on that and alerted, that would be a good example of DOM. So it's reading something, and then the script on the page through your browser is going to take what is presented via that JavaScript, and it's going to represent or take action on that back to you. So that's going to be somewhat local. Reflected involves actually bouncing back from the server. So in this case, when a user requests information from a server, the display back information after it has been processed by the server is where the script will actually render and cause some sort of activity or something to happen and run inside of their browser. So DOM is more local based, where it's not actually getting bounced off of the server. It is a local reflection though, whereas reflected is really going out to that server, and then that server processes the input and reflects back something that could have potential malicious intent via the running of those JavaScript code snippets. All right, so this is just a quick look at a reflected cross-site scripting scenario where an attacker sends a malicious URL to a victim. There we go. So this is that idea of phishing. So the attacker has to obviously identify the cross-site scripting flaw in some web application. They're going to send a URL to the victim. Remember I talked about Google and a cat search versus Google with a search where I inject something into that URL behind Google that is malicious. Well, that's what I'm going to go ahead and send to my victim, okay? And then the victim's going to click on that URL, and the attack sent to the application, the URL is going to send something to the Google server with that attack information attached to it, because that's in the URL. But again, the victim sees that it's Google, and the victim trusts Google, so they click on it. Well, that malicious script is sent to the server and then reflected back. So the server takes some action and reflects something back to the victim, and then the browser renders what the server produced and executes that action. In this case, we're really talking about stealing sensitive information like a cookie, as we just looked at. So what's happening is that maybe in this case, that cookie or that session information or credential or something of that nature that belongs to the victim, the browser, what the attack execution is going to do is make that browser render the site and then actually copy some information and send it out to the attacker. So again, this is something specifically that you will be doing today in your Labtainer exercise. And I will tell you that for your exercise with Labtainer, you will have to play the attacker, the victim, as well as you will have access to a open source social media or social networking website that is going to be spawned for you. It has a full GUI front end, so really you're going to be doing, initially anyways, a lot of stuff through the website as if you were using that social networking platform. All right, so now we get to try it. So first, what you'll need to do is looking at this particular form. That's what's outlined in red. You're going to have to find the field that's susceptible to cross-site scripting. Now, validation is how we are able to basically mitigate this type of vulnerability. So when we talk about validating, it's a very good practice to validate input. So this cross-site scripting can happen when unvalidated user input is going to be used in the response. So that means the server never validated the input, and then that allows us to kick something back. So What I want you to do is go through this and look at this. You'll see here it mentions an easy way to find out if a field is vulnerable to cross-site scripting is to use that alert or console log method. I like the alert method because it just pops that window up at me. So use one of those methods to figure out which field in this form is vulnerable to cross-site scripting. Basically, all you have to do is use the script tags with the alert function, and then something inside of that alert. It could be something like a message, it could be asking for a cookie, but something inside of that alert that'll pop up in that window. So try that in various fields within this form. The form is outlined in red, and once you get the correct item, when you hit purchase, you'll see it down here at the bottom. It'll tell you if you are correct or not, okay? So I'll let you go at this for a little while, and I will mention to you before I pause and let you try this for yourselves that if you look at the very top, if you get lost and you just don't even know where to start, use show hints, okay? Once you show hints, you'll see a little arrow in there and you can actually go to the next hint and the next hint. And if you make it through all of the hints, they pretty well just tell you the answer. So don't get too hint crazy because they will give you enough information to do this very easily. But if you do get stuck or this is something that's very unfamiliar to you, then go ahead and use those hints to get you started. If you want to reset this and try it again, or do it without the hints, you can go ahead and hit the reset lesson up here. So I will let everyone I'll give everyone a few minutes to give this a try. Again, don't forget that there are hints up here if you are lost, and you're welcome to go back to these tabs. I suggest going all the way back to tab 2, where you see this right here. This is the syntax that you can use as an example to create a test alert window that would pop up at you. So again, tab 2 is going to give you some good information to help with this, as they mention here, but go ahead and try to find the field in this form that is susceptible to cross-site scripting. Okay, so I think we've had enough time there. I hope everyone was able to give this a shot. So I have Nicole monitoring live chat. Does anyone want to just throw into live chat if you got the answer, which of these fields is vulnerable to cross-site scripting? Does anyone want to go ahead and try to throw that out? Tell us which field it is. Wow, really? Did anyone try? I hope so. So I will say, you'll notice that if I try to type something in here, really doesn't like that. And it says, please enter a number. That is correct. Who gave us the correct answer?
Daryl. He was my CCNA side-romp student.
Well, Daryl is all over it because Daryl has been like hard charging on the labs. Well, we gave him a shout out yesterday. That's correct, Daryl. The credit card number field is the one that is susceptible. These fields up here are actually filtered to validate and only allow for numbers to be input into them. And same with this 3-digit access code. This one will not actually allow for cross-site scripting. But if we throw something into this credit card number field, you'll see that when I put in that script alert with the cross-site scripting test as the text, it will throw up an alert that says cross-site scripting test. So this alert window is based on this script being executed because this particular field, the credit card number field, is not being properly validated, and therefore the input is being taken by the page and run as JavaScript rather than being scrubbed and just invalidated. So as far as the lesson goes, we are not going to cover 8, 9, 10, 11 in person during the lecture. I will say that you are welcome to go over 8, 9, 10, 11 and do those yourselves. I would like you to attempt to do the quiz at the end of 12. If you don't get it right, just reset it and try again. But I would like you to do the quiz on 12. You should be able to do the quiz without going through the actual exercises in 10, 11, but it's just kind of a check your knowledge quiz. So I'd like you to attempt that. And when you are ready, once you have reviewed all this information well enough, you can attempt to do your lab. And what I'm going to do is I'm going to pull that up for us because the lab is a little bit more robust than some of the labs that you guys had yesterday. So I'm going to make sure we pull that up and show you, just get you a little bit familiar with that. So as I let this pull up, in your lab prompt, you should see a bit of a diagram that gives you an idea of the different boxes that you're going to be working with in these terminals. So you do have an attacker box, you also have a victim box, and you have the ability to access the social media website, which is going to be the eLig site. And I'm going to go ahead and pull up our prompt. So you'll see here in your prompt this scenario letting you know what you need to do. This is your environment configuration. Again, you'll have a terminal for victim, for attacker, as well as for the vulnerable type. So you'll see these 3 terminals deploy. The Apache server should be started up, so you do not need to worry about that. But if for some reason something goes wrong and you can't get to the website, it may be that the Apache web server died, so it would need to get restarted. And if that happens, you can do this, or you can just stop and restart the lab. But you should not have any problems with that. If you did, this would be a command to restart that web server that is controlling the site. Here you have some information about all the users on this social networking site, their username, their user, like their actual name, their username, and their password. So again, actual name, username, password. Now for this, you'll see some things that look very familiar. You should recognize this first one directly from WebGoat, where we're seeing the script and the alert. In this case, we just put cross-site, XSS. Really, this message inside of those quotations can be anything you want. It can be like, I'm rad, or Sammy won. It can be anything you want. It's just what's going to be inside of that alert window. So again, you should recognize this from that lab. And then if you will read this carefully, this will talk to you through how you can actually reference a longer script. So obviously this alert is a very short script. This would give you information on how to reference a longer script to execute. This again should look familiar as far as the cookies and how we are pulling those. And then you're going to get into the meat. This is where we start looking at how we can steal cookies from the victim's machine. So you'll do some things here as far as getting the cookie and testing that on the site. So first you have to figure out how the site's vulnerable. Then you'll go in and actually steal the cookies. Now, with that being said, you'll notice that there's a whole lot of information here that gives you token and all sorts of information in an HTTP request that's very important to you, okay? So do read through this very carefully, and if you are able to get through the countermeasure, that is fine. It is totally optional whether or not you do the countermeasures. But remember that when you are done with this, do the stop lab at the end or it will not grade for you, okay? So again, countermeasures is optional. You should be able to get all the way through here. And again, if you read this, you will find that there is an actual attack program that is written, and it is something that you can access and hard code information in to run. So most of the attacker program is written for you, so you don't need to know JavaScript. But try to make it as far as you can through this. It's a really fun lab. I'm gonna pull this back over here, up. Should have pressed enter. And you'll see that I have victim. So this terminal is for my Ubuntu victim. This is the vulnerable site right here, okay? And then you'll see my attacker up here. So in the victim one right here, I'm gonna pull up Firefox. I'm gonna show you how you're going to be accessing that front end website. And let me just get the website. It is www.xsslabelig.com. Oops. I think that's right, or I don't, maybe there was no dot there. Okay, so this is fine. You get the insecure connection warning because it is HTTP rather than HTTPS. Oops. Oops. Uh-oh. Did I get that right? Hang on. lablgg.com. There we go. Sorry, I had the S in there. No S. Again, this is HTTP. So we have www.xsslabelgg.com. So this is our website. One bad place. This is your social networking site. Obviously, this is where you would log in. You can log in with the credentials that you find here. You can act as Alice, use the username Alice, and then seed Alice as your password. So I'll use Alice and then seed Alice, and I will log in here. Don't save. Uh-oh. Did I do that wrong? Let's see. Alice, seed Alice. Let's go ahead and do Bobby. I always mistype this, by the way. There we go. So Bobby got in just fine with Bobby. So here we're inside of Bobby, and I can look at other members on this site. See, here you'll see Sammy, Charlie, Bobby, Alice, admin. I'm logged in as Bobby. So Sammy is going to be the bad guy. Obviously, call back to Sammy Worm, as you remember from the beginning of this lesson. So again, this is the actual social networking kind of web page. This is based on an open source framework, so it is a real thing that can be customized, but the protections that it does offer for cross-site scripting have been commented out or removed to make this vulnerable for this particular exercise. So with that, I will let you guys go with the note that if you did not catch the beginning of our session and you did not catch the patch, there is another patch available. There's still a small number of users that were impacted by the grading issue. So if you go ahead and do the git pull command inside of your browser, that's gitpull, I will pull up a browser in my window and show you in a second. Just got to get it sorted out here. If you do that, that will allow you to go ahead and update your grader. So you'll see it's gitpull, that is all you need to type. So you'll see that this machine had not been updated with the latest patch, so we did this went ahead and updated it. Now after that update and patch is applied, you will need to start and stop a lab in order to get all of your lab grades uploaded. If you are still having issues, then please contact us, but I will tell you that our engineer took a look at a couple of folks that reported some issues, and those folks were not properly starting and stopping their labs. They were closing terminals or not issuing the stop lab command in the correct area and then closing terminals. This means that their work was not being saved, recorded, or graded. So make sure that the start and stop command are both going to be done from your host operating system window. You should see the GTA_user at inside of the window where you're doing your start lab or your stop lab commands. Okay, so that covers it. If you will be so kind as to give us a few minutes so that we can get upstairs, get situated, and we will get those help live WebEx rooms open as soon as we can. Just give us a few minutes to collect ourselves and get those sites open, and then we will be with you to try to help with any issues you have on the labs.